Number 11, object is undergoing simple harmonic motion. For this object, what's the phase difference between the variation of displacement with time and the variation of acceleration with time? Well, we know that displacement can be written as A sine omega t. So if we differentiate this, we get the velocity that's equal to A omega cosine omega t. And if we differentiate this again, we get A is equal to minus A omega squared sine omega t. So it says, what's the phase difference between the variation of displacement with time and acceleration with time? So displacement is A sine omega t, and acceleration is minus A omega squared sine omega t. So there's no difference of pi over 2 radians, and for the difference between displacement and acceleration is going to be pi radians. So the answer is D, pi radians. Okay, number 13. Longitudinal wave travels along a horizontal spring. The frequency of the wave is 4 Hertz and the speed of the wave is 2 meters per second. Well, it appears, just on reading this question, the answer is D. The speed of the wave is 2 meters per second here. And the wave travels at a constant speed of 2 meters per second. So here. It appears to be D, but we look at the frequency. The frequency is equal to 4 Hertz. Therefore, the time period must be equal to 1 over 4. So that's equal to 0.25. So it seems to me C is a possibility as well. So I can only say I don't know what the answer to this question is. It could be C, could be D. Number 14, unpolarized light is incident in a pair of polarizers. The polarizing axis of the second polarizer is 60 degrees. 60 degrees to the axis of the first polarizer. The light emerging from the second polarizer has an intensity I. Cosine of 60 degrees equal to 0.5. So what's the light intensity on the first polarizer? So we know that I is equal to I naught cos squared theta. We're given cosine theta is equal to half. So this must mean that the light here must have been 4I, because according to our equation here, it's going to be half cosine squared theta, so that's going to be a quarter. So the light on the left hand side here must have been reduced by a quarter, so the intensity must have been 4I to get I here. The first polarizer, we know that when light passes through a polarizer, its intensity is reduced by 1/2. So this must have been 8I here. So the answer is 8I. Number 15. Electrons are moving in a long wire that's normal to the plane of the paper. The electrons move into the paper. What's the direction of the magnetic field at the point? So we have to know Fleming's right-hand rule for this. And we also have to know Fleming's right-hand rule uses conventional current, not electronic current. So it says the electrons are moving in a long wire that's normal to the plane of the paper, and the electrons move into the paper. So if you point your thumb at the paper, that gives the electron direction, but you have to use conventional current, so you have to reverse your thumb. So the magnetic field using Fleming's right-hand rule will look like this, and that will mean at P the magnetic field will be C. Number 16, what is the possible unit of electrical resistance? Well, we know P is equal to I squared R. So then power is watts and current is amps. That's 8 to the minus 2, so it's going to be equal to R, so the answer is A. Particle with charge Q is accelerated from rest through a potential difference V over a distance S. The particle then enters a magnetic field of strength P at right angles to the magnetic field direction. What single charge will make the radius of curvature of the path of the particle smaller, a single change? Okay, well, obviously if you increase the size of the magnetic field direction, this will make the curvature smaller, so the answer must be A, increase P. So this one, number 18, about an object of mass m is attached to the end of a rope. The object is rotated in a horizontal circle at the end of the rope with an increasing speed. The rope breaks when the angular velocity is reached. Okay, so for this, we must know that T is equal to m omega squared r. So when the rope breaks, the tension must be equal to m omega squared r. So we just have to work our way through these different combinations of masses and angular velocity. So if let's just look at D then. This is going to be 4m omega squared all over 2, all over, that's going to be 4 times r, so these cancel then, 4 is cancelled, so that means T is equal to m omega squared r, so the answer is D. Okay, number 19. What are the 3 fundamental forces listed in decreasing order of strength? Well, this is a knowledge question, so the answer is C, strong nuclear, electromagnetic, and gravity. Number 20, which equation is an example of beta positive decay? So beta positive means positron, so therefore we can eliminate A and B. We know the answer is going to be C and D immediately. And in positron decay, the emitted particle is a neutrino, so the answer is D. The answer is D. 21. The rest mass of an O17 nucleus is m0. What's the binding energy of a 17,8 oxygen nucleus? So the number of protons is 8. So we know the answer is going to be immediately either A or B. And the number of neutrons is 9, of course, because 9 and 8 is 17. So to get the binding energy, we have to subtract the total mass of the protons and neutrons from the actual mass of the nucleus. So the answer is A, 8mp plus 9mn minus mo. Number 22, 3 changes that may affect climate are. So options 1 and 2 will reduce the greenhouse effect. Option 3 won't, because changing from natural gas will still produce a lot of from natural gas to oil, will still produce a lot of toxic gases like CO2 and whatever. So the answer is A, 1 and 2.